Hello, my name is Zachariah Brown, and I'm a researcher at the University of Michigan studying Hall effect thrusters and electron transport. Hall thrusters generate thrust by ionizing a gas and accelerating it using electric fields. The gas is ionized by electrons traveling from the cathode to the anode, where they collide with neutral gas along the way. One of the problems in these devices is that they constrain the electrons from just free streaming towards the anode by radial magnetic fields that you can see here in this figure. Their electrons are trapped by these magnetic fields, and it makes it an efficient ionization source. But what we measure in experiment is that electrons actually travel across these field lines at orders of magnitude higher than we would predict. One of the reasons we think this is instead of it just being due to when the electrons collide with the neutral gas, it actually might be a complex interaction of the electrons interacting with waves and various instabilities that develop inside the Hall thruster. My research focuses on studying these waves and their impact on this electron transport problem. Primarily, I use experimental methods where we can inject probes and in some cases use laser optics to measure the amplitude, wavelength, and frequency of these oscillations. Using that information, we can categorize what type of instability is occurring and how strong it is, and in some ways infer how strong its impact is on anomalous transport. One of the prime instabilities we consider for being responsible for this enhanced transport is the electron drift instability. This is a very small, millimeter scale, much smaller than your eyes can see, oscillation that very, very rapidly oscillates on the order of several megahertz. So you'll never be able to see it even with a very fast camera. And the idea is that this wave that travels azimuthally around the thruster is effectively colliding with the electrons and taking energy from them, allowing them to cross the field lines more efficiently. What we can do with my research at the culmination of taking all of this oscillation data is then we can apply it to some very complex plasma theory, which is just a lot of math, and we can use the measured instability strength and growth rate, so that's the rate that energy is being extracted from the electrons, to infer what the anomalous transport level is, so the rate that electrons are traveling across field lines. This has historically been a difficult question to answer and has precluded predictive models for Hall thruster simulations. But using this information, we might be able to get one step closer to properly modeling these Hall thrusters and getting predictive models. Thank you.